Scatter plots and lines of fit. So what we want to do first here is look at some scatter plots. And I actually want to look at three different ones. There are positive correlations, negative correlations, and no correlations in scatter plots. Correlation just means how are they related? They're related positively, negatively, or they're not related at all. So for a positive one, if we go to graph a scatter plot, and a scatter plot is just dots, but it's literally, they're supposed to be random. That's why it's called scattered. So if you look at this graph right here, the dots are kind of scattered, but they do have a trend. They're working their way up as they go across. So they're kind of making this angle heading this direction. This is positive because it's heading uphill. And I can easily see this trend here. Negative correlation is the opposite. So again, it's going to be a scatter plot. There's going to be like random dots. But we should kind of notice that this line, and that is a terrible line. Let me undo that. We should notice that this line kind of goes downhill like this. As it goes downhill, that is a negative correlation because we're going down with the dots. No correlation, well, no correlation simply means that the dots are all over the place and I can't really tell, like, what is this pattern? I have no idea. I can't go, they're going up, they're going down. So that's no correlation. You also might get these things called outliers. So you can see in the positive correlation here, this is a strong correlation. They're all kind of going uphill to the right. But every once in a while, you might get a random dot. Let's say something out here or out here. This is still a positive correlation and still fairly strong. We've just got these two weird ones, and those are called outliers. They're things that don't really fit with the normal data. So let's look at some problems they may ask you. It says determine whether each graph shows a positive, negative, or no correlation. If it's positive or negative, describe its meaning. So what we want to do is, let's pick a color here, red. And I see these dots, they are pretty much going downhill. Now you can see there are these two here that don't really fit, but for the most part, almost all of my dots are going down. If all of my dots are going down, then this is negative. And if it's negative, then it tells me that we have to describe its meaning. We always describe the meaning using our axes. So this is years and this is hours. So my meaning would be as the years pass, the hours worked weekly in the US goes down, and that down is our negative. So as the years pass, the hours of the average work week go down. All right, same thing with number 2, average jogging speed. I can see an easy downward trend here, so this is negative. Sorry about the bad handwriting. I'm trying something different, and well, I have bad handwriting to start with. We can see then that this is negative because the line goes down. We need to describe its meaning. The average jogging speed, all right? We're going to look at our units here, minutes, miles per hour. So as the minutes pass, the miles per hour of the average jogging speed goes down. If this had been positive, then it would be going up. All right, let's do the same thing here. Let's do green. Okay, this is a very obvious positive trend. That line is going uphill. Okay. Positive. All right, then let's describe it. As the years pass, the hourly earnings in the US go up. Line's going up, that's a positive trend. We have to describe it. Oh, I guess we should write positive. All right, if we describe it, I'm looking at my labels again. That's years, and that's imports in billions of dollars. And this is US imports from Mexico. So as the years pass, the billions of dollars of imports goes up. All right, it says refer to the table for exercises 1 through 3. Okay, so this is 1, 2, and 3. It says draw a scatter plot, and you notice it gives me a table over here. So I'm going to switch to blue. We're going to put a dot at 0 and 5.08. Well, now my units over here don't have 5.8, but I'm going to say that's about right there. So we're going to put a dot right there. 1 and 5.39. So there's 1. Oh my goodness, why did it do that? Ooh, it switched tools on me. That's why. All right, so we're going to do 1 because of the 1, and we're going to go 5.39, which is almost a 5.4. 2, 5.66. So there's 2. 5.666 be about there. Stop doing that. 3 and 5.81. There's 3. 5.81 to be about there. And then 4 and 6.03. So there's 4, 6.03 be about there. All right, so we drew a scatter plot. Now, these dots line up pretty good, but if it's a scatter plot, they could be all over the place. It says draw a line of best fit for the data. So let's switch colors here, see how well we can do. Now, this should be a straight line when you draw a line of best fit, but that's the best I can do with my cruddy little setup here. It says write the slope-intercept form of an equation for the line of fit. Okay, so slope-intercept form is y equals mx plus b. The m is the slope and the b is the y-intercept. So what we have to do is go in here and we're going to find the y-intercept and we're going to find the slope. Well, the y-intercept's easy because the y-intercept is always where the x value is 0. That means my y-intercept is 5.08. So if I write y equals, it's going to be some number for my slope, x plus, and then it's going to be 5.08. So we need to find the slope. The easiest way to do the slope would be to pick 2 nice points on my line that I wish I drew a little better. But let's say there's a dot right there. And where's another nice one? Oh, maybe right there, even though I didn't do the greatest of job. All right, so I'm going to do rise over run. So it goes up from 5.6 to 5.8 to 6. That's a change of 0.2, 0.4. So it changed 0.4. That's my rise. And then it went 1, 2 spaces over, and that's 2 to 4. That's a change of 2. Ooh, that's an ugly 2. Change of 2. So this is 0.4 over 2. Now, I don't want this decimal inside here. So what we need to do is actually divide or simplify this fraction. And it's going to simplify out to 1 over 5. So my slope is 1 over 5. So my equation is y equals 1 over 5x plus 5.08. And honestly, we're just eyeballing the line of best fit. So yours may not come out to be exactly the same as mine. It just depends on where you chose your dots. But hopefully, it's fairly close to what I got here.